Hi guys, we are going to take a look at splitting up ions from ionic compounds. So you're going to watch this video, and then on the slides that follow you'll get some practice with this. I'm going to show you some examples and we will go from there. So how do we split ionic compounds apart into their ions? So a skill expected in AP chemistry is not only the ability to form ionic compounds, so to take our two ions, do the crisscross and put them together, but also to split compounds into their ions, so kind of reverse that. This is key because this affects the dissolving of ionic compounds, their chemical reactions, and how we analyze certain properties of the compounds. Being able to see and split up the ions is crucial. So we have some steps we're going to take to do this. The first thing we're going to do is look at the first element in the compound and ask ourselves, is it a metal? If it's a metal, if your answer to that is a yes, then we're just going to draw a line after that, vertical line, to kind of split things right after that metal. If our answer is no, if it is not a metal, then what you're going to see there automatically is the polyatomic ion NH4 plus ammonium, and we're going to split it up after that. So it's either a metal, and it can be a alkali metal, alkaline earth, transition metal, it doesn't matter what kind of metal, but it's a metal, or we'll see ammonium. Those are our two options. After that, we're going to split it and just write the symbol of each ion. Then we're going to do some work to kind of uncrisscross the subscripts and make the charges. Now with that is a little bit tricky. We do need to check our periodic table to make sure that we have the correct charges, that something wasn't reduced to form that ionic compound. We just want to make sure we've got the right charges there. And then we are going to use coefficients, so numbers out in front of our ions, to show how many of each ion there is. And we get that from the subscript as well. Okay, so we're going to go through these steps together on some examples here. So on this next slide, we have some examples. So our first one there is Ca3P2. So our first question is, I'm going to adjust my stuff here so we can look at it. Our first question is to look at that first element. Our first element there is Ca, or calcium, and we want to ask ourselves, is it a metal? Well, calcium is most definitely a metal, so we're going to split this right after calcium. So I just divide it in half right there. Then we want to write the symbol of each ion. So we have calcium and we have phosphorus. Next, we're going to kind of uncrisscross the charges. So it says Ca3P2. Well, the 3 would become the charge on phosphorus, and our nonmetals become negative. And the 2 would become our 2 plus charge on calcium. Ooh, drawing is a little messed up there. There we go. Because calcium is positive because it's our metal. So we can uncrisscross. Now we would want to double check on our periodic table. Calcium is in the second group, so that's its charge. Phosphorus is in group 5, and those get a 3 minus charge. So we're good there. Nothing was reduced. And then our last step is we want to add a coefficient out in front. The coefficient's job is just to tell us how many of that ion were present. And we're going to base that off the little subscript again. So Ca3 means that there were 3 calciums in this compound. And P2 means there's 2 phosphorus ions in this compound. So we have 3 calciums and 2 phosphorus ions. So we have a total of 5 ions in this compound. Okay, we're just adding those two things together. 5 ions. And those subscripts, the subscript tells us how many of the element or ion we have in the compound. So we're just relating that and putting that out front as a coefficient. So we're going to try another one here. We'll go to the right over here, NH4Cl. So our first question, we want to look at that first element. Is it a metal? Well, nitrogen there. Nitrogen is a non-metal, so that's a no. Well, if it's not a metal, then we're going to see NH4, and we want to split it after the NH4. That's our ammonium. Okay. Then we're going to write the symbol for each. Well, ammonium's symbol is NH4. Remember that 4 sticks with it. It's a polyatomic ion that's going to stay together. And then we have Cl. Now we need to be careful with this in terms of the quote uncrisscrossing. We have 1 ammonium, 1 NH4, and we have 1 chlorine. So when we uncrisscross that, we get NH4 plus and Cl minus. We do not move this 4 because it's part of that ammonium. That whole NH4 has a positive charge and that chlorine has that negative charge. And then our coefficient on each would just be 1 and 1. So we have a total of 2 ions in this compound. 1 ammonium and 1 chloride ion. All right. And those polyatomic ions are where things can get a little tricky, so we're going to do some more practice with those. All right, this next one, calcium, CaOH2. It's nice when we have parentheses. It gives us a natural division between things. But we can still go through our steps. First element is calcium. That's our metal. We're going to split it right after that calcium. There we go. Just gotta be a little more careful with my division line there. So we're going to have calcium and OH. We're going to keep the OH together because they're both together inside that parentheses. And that's our hydroxide ion. Now we want to uncrisscross. Well, calcium, there's only 1 of those, so hydroxide would just have a 1 minus charge. And there are 2 hydroxides. That's what that 2 outside the parentheses means. So this would be a 2 plus charge. We can check our information. Calcium is in group 2. It's still a 2 plus charge. Hydroxide is always negative. So those are consistent. This is where getting to know your ions, your polyatomic ions, things like that is going to be really important and really helpful. In years past, I've actually done memorization tests on the polyatomic ions. This year's a little different just because of our situation, a little harder to do. But we will probably do those in the springtime. So make sure we've got these down. All right, now we want to put our coefficients. Well, in our compound, we have 1 calcium. And we have 2 hydroxides, so we have a total of 3 separate ions. All right, let's go down here. We'll do this one at the bottom. All right, so we're splitting this after the calcium. That's our metal. So we've got calcium. And then the sulfate, SO4, that has no parentheses around it. That is our whole polyatomic ion that has to stay together. If there were parentheses, then we would know that there's more than 1 of those, okay? So the parentheses really help us out in terms of, do we move the little number at the bottom or do we not? If there's parentheses, like in the previous one, hydroxide, there was the parentheses, and then the 2, we move the 2. But there's no parentheses here, so we're going to leave that for where it is. All right, now there's nothing to uncrisscross here. We have 1 calcium, we have 1 sulfate. So we might assume that calcium is positive and sulfate is negative. However, if we look up calcium on the periodic table, it's a group 2. It has to be 2 plus, which means sulfate has to be 2 minus to balance out that charge. Again, we have 1 of each. So those would be our coefficients, and we have a total of 2 ions. All right, going on to this right side. Again, we look at the first part. It's in parentheses. We can see it has that NH4, so that's a natural thing to help us split this in half. So we have our ammonium, NH4, and then we've got our sulfate, SO4. Notice the 4s both stayed with those. Now we've got this 2 on the outside of that parentheses. That's going to tell us there's 2 of those ammoniums. So we can go ahead and put that out front, 2 of those. We got 1 sulfate, so that can help us out. And then our charges, again, this is really where it comes in handy to know these charges. But if there's 2 ammonium, hopefully we can remember that they're positive. Ammonium is a positive charge. And if there's 2 of those, we need a 2 minus charge on sulfate to balance that out. And to get our charges adding up to 0. And we have a total of, not 2 ions, we have a total of 3 ions there. All right, our last one, we look at it, we've got lithium. Lithium is our metal, and you might go, well, manganese is a metal too, but we only separate it after that first metal. The second one, manganese, is part of a polyatomic ion. So we've got lithium, and then MnO4, permanganate is that ion. Again, the 4 stays with it. There's no parentheses, so the 4 is part of that compound. We don't have 4 MnOs, we have MnO4, okay? Hopefully that makes sense. If there were parentheses, if you had like MnO4 and you had more than one of them, like a 3 outside, then that 3 would be our coefficient, and that would help us with our charge. Well, since there's one of each of these, we have just one lithium ion and one permanganate ion, then we want to get our charges, so we would assume that they're positive and negative. And we look at lithium, it's a positive 1 charge. That means permanganate has to be a negative 1 charge to balance it out. And then we have a total of 2 ions here. Okay, so hopefully that's making sense. We're seeing how we can divide these things up, how we get these ions. Again, it's going to be really helpful to be checking those polyatomic ions, making sure you got the correct charge. And anytime you see these, you have those polyatomic ions, if it has parentheses around it, then that number outside is going to be what you can move. If it doesn't have parentheses, like you see, what's a good one? If we saw Ca, no, that's a bad one. If I saw KOH, right, I see 3 different elements, split it after my potassium, that OH has no little subscript, so we're not going to move anything. Trying to think if I can come up with any other examples here real quick. If you saw something like let's try that one, calcium phosphate. So we would split it after the calcium. Erase some of this so I have some space up here. We'd split it after the calcium, so we get Ca, and then that part inside the parentheses stays together. We can go ahead and put our coefficients out front. We have 3 calciums and 2 phosphates. Oops. There we go. And we can also uncrisscross. So the calcium 3 means phosphate has a 3- charge. PO4 2, that means calcium has a 2+ charge, and that is consistent with our periodic table. Okay, so this would have a total of 5 ions. All right, hopefully that helps you guys out, and we can do some practice with that. Thanks, guys.